look at this beautiful weather here. I'm out here in this gorgeous day, and I thought that we would make a couple of calculations. So here's the problem. All right, so the other day I used similar triangles and shadows to calculate the height of this beautiful tree, and it is 52 feet 6 inches. Okay, 52 feet 6 inches. And I also calculated the distance from the base of that tree to this rock over here, and that was 28 feet 4 inches. Okay, I have heard from all. Do you hear all the birds?
Yes.
I can hear them now. I've heard that this spot over here by this rock is like the best spot to get worms. Okay, and it is supposed to be 55 degrees today, so I don't know what's gonna happen, but I know that the bird that's all the way on top of the tree is thinking, I wonder if I'm gonna be able to go to my worm spot today. So he's thinking, should I get down? What's gonna happen? This bird is a little bit lazy. This bird doesn't like to do a lot of flying, so he likes to do the smallest amount of work possible. Okay, and so I would like us to figure out how far, it's the shortest distance. The shortest distance from where that bird is to the worm spot would be this diagonal. And I would like us to calculate that distance, the distance that he would have to fly in order to get to that golden worm spot, because apparently, I don't know, that must just be a great place for worms to live. So let's do that. All right, so in the time that it took me to calculate this, the snow all melted. But what we're going to use to calculate this is the Pythagorean theorem. Okay, and that's kind of a review actually, but in a right triangle, remember a squared plus b squared equals c squared, and a and b, they're interchangeable, but they're both the legs, and then c is the hypotenuse. Okay, so if you look at our tree, which was 52 feet 6 inches, and then the base of the tree was 28 feet 4 inches from the worm rock, which now is covered by a hammock. So what we're going to do is we're going to calculate the distance that the bird has to fly. Okay, and do that right here on this board. Okay, but what we need to do is we need to put it into just inches. Sounds great. Okay, we are going to change this to inches. So we have 630 inches here and 340 inches here to find that distance. And so we're going to plug that into the Pythagorean theorem. Okay, and so we end up with 512,500 is equal to c squared. And so we just need to take the square root of that. And the square root of that is approximately 715.89 inches, which is approximately 59.66 feet, or 2/3 feet, which is about 59 feet 8 inches. So the bird needs to fly from the top of the tree down to that rock 59 feet 8 inches to get to his destination. Alright, so here is a right triangle, and if you look, there are 3 tiles on the bottom, 4 for the other leg, and then 5 for the hypotenuse. Okay, and so that's my triangle, and if I pull this up here, the square on each side, the one on the base becomes a 3x3 square, a 4x4 square, and a 5x5 square. So that means we've got 3 squared on the bottom, 4 squared for the other leg, and 5 squared. So those numbers become 9, 16, and 25. Okay, so a squared plus b squared does in fact equal c squared because 9 plus 16 equals 25. All right, so we just talked about the Pythagorean theorem, and these are some common Pythagorean triples, and what that means is that the two numbers, this is our a, our b, and our c, so that means 3 squared plus 4 squared does in fact equal 5 squared, so 9 plus 16 does equal 25, okay? 5 squared plus 12 squared equals 16 squared. These are called Pythagorean triples. They are numbers that work in the Pythagorean theorem where the numbers are all whole numbers, okay? And one more thing with the Pythagorean theorem, okay, the Pythagorean theorem is for a right triangle where c squared is equal to a squared plus b squared, but if you're looking at the side lengths of other types of triangles, in an acute triangle, the c squared is less than a squared plus b squared. In an obtuse triangle, the c squared is greater than a squared plus b squared. Okay, so we're actually going to look at some numbers and we are going to figure out what types of triangles they are. All right, so let's look at 7, 8, and 16. Okay, first we have to make sure that these legs would make a triangle. And remember, to test that, we add the two smaller ones to see if they're greater than the third. Is 7 plus 8 greater than 16? No, it's not. So that wouldn't even make a triangle. Okay, so we don't need to find out what type of triangle that would be. The next one is 12, 16, and 20. Does 12 plus 16 equal greater than 20? It does. So we can continue. So we're going to look at our a squared and our b squared. Those are our two smaller ones. So 12 squared plus 16 squared. And see if that equals 20 squared, or if it's less than 20 squared, or if it's greater than. That's why I put a little question mark above. Okay, so we've got 144 plus 256. That actually equals c squared. So if our c squared is equal to our a squared plus our b squared, then that means it's a right triangle. So actually this one's pretty cool because this date, 12/16 of 20, so December 16th of 2020. Hi, Sunny. December 16th of 2020 is actually, obviously happening this year. So December 16th of 2020 is Pythagorean Theorem Day. Yay! Okay, so we can celebrate that. Are you excited? All right, now let's look at 2, 3, and 4. And 2 plus 3 is greater than 4, so we can continue. 2 squared plus 3 squared, we want to see how that compares with 4 squared. So we've got 4 plus 9 and 16. And since 16 is greater than 4 plus 9, then it's an obtuse triangle. And now we've got 6, 7, and 8. Okay, so 6 plus 7 is greater than 8, so that's a triangle. We can continue. 6 squared plus 7 squared, we want to see how that compares to 8 squared. So then we have 36 plus 49, and we want to see how that compares to 64. And since 36 plus 49 is 85, 64 is less than 85. So that means that this is an acute triangle. Good morning, class.
Good morning.
Today we're going to talk about shortcuts.
Yay!
Can anybody think about what it means to have a shortcut?
I don't know.
Maya.
Okay. For example, if you're late for school and you find a shortcut, then it makes it quicker.
Good, good. Can anybody else think of a shortcut? Chase.
When you find a shortcut, you go in the ocean and go faster.
Okay, all right. Chase?
You might find a shortcut when you go on a hike.
Good, good. Anybody else? These are all good shortcuts. Can anybody think of a bad kind of shortcut? Yes, Madeline.
So if you are taking a test and you forgot to study and you look at someone right next to you and you look at their answers.
Yes, that's a bad shortcut, right? Yep. So today, boys and girls, today we're going to talk about some shortcuts that will help us find some sides of triangles. Doesn't that sound fun?
Yes. Yay!
All right. Well, thanks for joining us today, class.
You're welcome.
Talk to you later.
Bye.
All right, so now for these shortcuts you've all been waiting for. Okay, so shortcuts for right triangles instead of using the whole Pythagorean theorem. These only work in special right triangles, and if their angles are either 45, 45, and 90, or 30, 60, and 90. Okay, so here is the 45, 45, 90 rule. Okay, if these two angles are 45 degrees, okay, that would mean that the legs are congruent and the hypotenuse is whatever the leg is times radical 2. So, for instance, this is going to be super easy. Like, it's going to be so easy that it's going to seem like it's hard. Okay, so if you look at this first example, if I know this leg is 4, I know that these angles are congruent, which makes them each 45 degrees. I'm going to find the other two pieces. Watch. Here. Okay, that leg's 4. This leg's 4. This leg is 4 radical 2. Done. Boom. That's it. Okay? And we can check this too. Like, we could go 4 squared plus 4 squared equals c squared. So then we've got 16 plus 16 equals c squared, or 32 equals c squared. Take the square root. C is equal to the square root of 32, which is the same as the square root of 16. Pardon my handwriting. I'm at an awkward angle. Okay, so then we've got radical 16 radical 2, which is 4 radical 2, which is what we found up here. But why not use the shortcut, because that is way easier. All right, so that's it. 45, 45, 90 rule says that if you know a leg, you know the other leg, and then the hypotenuse is that side times radical 2. Okay, you're welcome to use the Pythagorean theorem, but this is a lot quicker. Okay, the tough part comes when you know the hypotenuse, and when you know the hypotenuse, it's just a tiny bit more work. Okay, so the 6 has already been multiplied by radical 2, so we need to undo multiplying by radical 2. So we're actually going to divide by radical 2 to find the legs, because the opposite of multiplying is dividing. So we're going to divide by radical 2. Okay, so these legs actually would be 6 divided by radical 2. But remember, you can't have a radical in the denominator, because that is illegal, and we don't want to do anything illegal. So we're going to multiply the top and the bottom by radical 2. So on the top, we get 6 radical 2. And on the bottom, we have radical 2 times radical 2, which is the square root of 4, or 2. So we have 6 radical 2 over 2, okay, which is almost done, but we need to simplify this. So we're going to take 6 divided by 2, or 3 radical 2. So each of the legs on this triangle would be 3 radical 2. Good job, guys. All right, so no shortcuts when introducing this next rule. I'm going to try explaining it upside down. I'm going to try. That's the key word. All right, so 30, 60, 90 rule. Okay, so you have a short leg, you have a long leg, and you have a hypotenuse. Okay, the short leg times 2 gives you the hypotenuse, and the short leg times radical 3 gives you the long leg. So, for instance, if you look at this triangle here, the short leg is 5. Okay, that makes the hypotenuse 10, and the long leg, yes, you said it, 5 radical 3. Woohoo! All right, so a couple more examples here with the 30, 60, 90 rule. Sorry, my dog was in the way. Okay, so if you look at this one, the hypotenuse is 12, and remember the hypotenuse is double the short leg, so that would make the short leg 6. Okay, and then the long leg is the short leg times radical 3, so it's just 6 radical 3. Again, it's as easy as that. Like, there's nothing else to it, but sometimes it just seems hard because, you know, it is that easy. Okay, but if you look at this one, oh, and I didn't put these angles here. This one's 60. This one's... In order to find the short leg from the long leg, we need to undo multiplying by that radical 3. So we're going to take 9 divided by radical 3. Okay, and remember that's illegal. We can't have a radical in the denominator. So we're going to multiply by radical 3 on the top and the bottom. And we get 9 radical 3 over 3, which is also 3 radical 3. Okay, so what? Pardon that interruption. Okay, so that is our short leg. So the short leg is 3 radical 3. Okay? And then to find our hypotenuse is double that short leg. 3 radical 3 times 2 would be 6 radical 3. And there it is. That's as hard as it gets. Alright, so I hope that these are the only shortcuts that you use on your math assignment.